Lecture 4. NDT Methods and Specimen Locations. Before we cut a single specimen from a test piece, we must satisfy a fundamental sequencing requirement. All non-destructive testing must be completed and the results must be acceptable before any test specimens are removed. This is not just good practice, it is a mandatory requirement of Clause 7.3. In this lecture we will cover all the NDT methods required by the standard, the specific rules about which methods apply when, and then the detailed rules for locating and extracting test specimens for destructive testing. Getting the specimen locations right matters enormously. Put a specimen in the wrong position and you might miss a critical area of the weld, or worse, waste material that you cannot replace. The NDT sequencing rule. Clause 7.3 is explicit. All non-destructive testing shall be carried out and accepted on the test pieces prior to cutting of the test specimens. The discard regions, which we will cover shortly, are excluded from NDT consideration. Furthermore, if post-weld heat treatment is specified in the PWPS, it must be completed before NDT is carried out. The sequence is: weld the test piece, then apply any specified PWHT, then do the NDT, and only after the NDT is complete and accepted do you cut specimens for destructive testing. There is one special case, for materials that are susceptible to hydrogen-induced cracking, and where no post-heating or PWHT has been specified, NDT must be delayed. The delay period depends on the material and the hydrogen risk. This aligns with your preheat and post-weld hydrogen management strategy. The purpose is to allow any diffusible hydrogen to escape before you inspect, so you do not get a false pass on a joint that may crack later. The delayed NDT rule for hydrogen-susceptible materials is frequently overlooked. Always check whether your parent material and joint conditions put you in this category. Low alloy high-strength steels and thick sections are the main risk groups. Quote: NDT methods, Level 1. At Level 1, the only mandatory NDT for butt joints with full penetration is visual testing at 100% of the weld. Visual testing is carried out in accordance with ISO 17637. However, and this is the important caveat we discussed in Lecture 3, if an application standard or specification requires impact testing, hardness testing, or additional NDT, those tests must be carried out and assessed in accordance with Level 2 requirements, unless the application standard specifies otherwise. So in many real-world Level 1 scenarios, you will still be performing Level 2 NDT. NDT methods, Level 2. At Level 2, the NDT program for full penetration butt joints is substantially more comprehensive. Let us go through each method. Visual testing, ISO 17637. 100% of the weld must be visually examined. Visual testing is always the first step and should be carried out before any other NDT method. It covers surface irregularities, weld geometry, spatter, undercutting, cracks, and other visible imperfections. Radiographic or ultrasonic testing. 100% of the weld must be subjected to either radiographic testing, RT, or ultrasonic testing, UT. RT is governed by ISO 17636-1, film-based, or ISO 17636-2, digital detectors. UT is governed by ISO 17640. However, there is a critical restriction on UT. It shall not be used for material thicknesses less than 8 mm, and it shall not be used for material groups 8, austenitic stainless steels, 10, 41, 42, 43, 44, 45, 46, 47, or 48, nickel and nickel alloys. For these materials and thicknesses, RT is the only permissible volumetric method. Additionally, for T-joints and branch connections with full penetration and for outside diameters of 50 mm or less, no UT is required. But RT shall be carried out provided the joint configuration will give valid results. Surface crack detection. 100% surface examination must be carried out on accessible weld surfaces. For magnetic materials, this is magnetic particle testing in accordance with ISO 17638. For non-magnetic materials, such as austenitic stainless steels and nickel alloys, penetrant testing per ISO 3452-1 is used instead. These methods detect surface breaking and near-surface defects that may not be visible to the naked eye, particularly fine cracks, porosity breaking the surface, or lack of fusion at the weld toes. Location and taking of test specimens. Clause 7.2 states that test specimens shall be taken in accordance with the relevant figure for each test piece type. Let us go through each. For a butt joint in plate, 25 mm are discarded from each end of the test piece. These end regions contain the start and stop of the weld, where the weld quality is typically less representative of steady-state welding. They are also excluded from NDT. Working from one end inward after the discard, Area 3 provides one tensile specimen and the bend specimens. Area 4 is reserved for impact specimens and any additional specimens required. Area 5 provides the second tensile specimen and more bend specimens. Area 6, at the far end after the second discard, provides the macroscopic examination specimen and the hardness test specimen. Figure 6, butt joint in pipe. For pipe test pieces, the end of the weld is identified, and the same zone structure applies around the pipe circumference. Area 2 and Area 4, on opposite sides of the pipe, each provide a tensile specimen and bend specimens. Area 3 between them provides impact specimens. Area 5 at the start of the weld provides the macro and hardness specimens. The hardness specimen is specifically taken from the start of the weld, not the end. Figures 7 and 8, T-joints and branch connections. For T-joints, the macro and hardness specimens are taken as shown in Figure 7, with a 25 mm discard at each end. 2 macro examination specimens are required, one for macro only, and one for macro and hardness. For branch connections per Figure 8, specimens A and B are identified at specific positions around the branch, with specimen A providing macro and hardness data and specimen B for macro only. A practical point on specimen location. The standard permits test specimens to be taken from locations that avoid areas which have imperfections within the acceptance limits for the NDT method used. In other words, if your NDT finds a small embedded pore that is within the acceptable limits, you may position your destructive specimens to avoid cutting through that pore, provided you stay within the zones defined in the figures. This is a practical accommodation, not a loophole. The acceptance limits of the NDT method still apply to the whole weld. The imperfection must be acceptable for the NDT. You are simply choosing to take your mechanical test specimens from the best available material, which gives the most representative results. Remind viewers, specimen location decisions must be documented. Record exactly where specimens were taken, especially if you are avoiding an NDT-detected imperfection. Recap, Lecture 4 Key Points 25. All NDT must be completed and accepted before any test specimens are cut. 26. Post-weld heat treatment, if specified, must be completed before NDT. 27. For hydrogen-susceptible materials with no post-heating, NDT must be delayed. 28. Level 1. Visual testing only, 100%. Application standard may require more. 29. Level 2. Visual testing, RT or UT, 100%. Surface crack detection, 100%. All mandatory for full penetration butt joints. 30. UT is not permitted for T less than 8 mm, or for material groups 8, 10, 41 to 48. 31. Surface crack detection, magnetic particle for magnetic materials, penetrant testing for non-magnetic. 32. 25 mm discard zones at each end of plate test pieces. These are excluded from NDT and specimen taking. 33. Specimens may avoid NDT-detected imperfections that are within acceptance limits. Quiz related to Lecture 4. Question 1. For a Level 2 procedure test on a 6 mm thick austenitic stainless steel, Group 8, butt joint, which volumetric NDT method should be used? Question 2. When must post-weld heat treatment be applied relative to NDT? Question 3. How large is the discard zone at each end of a butt joint in plate test piece?